Okay, so let's get back to where we started, where we left in the previous video. We were talking about this life cycle impact. If you remember from that example that I showed you, we had two different types. We have two types of bulb. We looked at their input and output in terms of what gets into making those bulb for that particular functional unit and the reference flow, and then what are the emissions. From the emissions, we can get that what is known as the midpoint indicators. If you had remember, we were talking about these are the midpoint indicators in terms of radiation, smoke, climate change, acidification. So, that is your midpoint. From emissions data, we can quantify in terms of what will be these values in terms of what is how much is the carcinogen, what is going to potentially how much is the ozone layer depletion potential. And using that, we can get these endpoint values, which we talked about in terms of extinction of a species, dying forest, respiratory disease. But if you take all these values like that and present to a common public, to the regulators, to the decision makers, to the politicians or the ministers, it becomes very difficult for them to follow. So, like we have example in the other domain in terms of air quality index, water quality index, or even BSc Sensex index, we have decided in terms of the LCA also, the goal is to put everything in terms of a single score. So, from the elementary flow, we get the impact category, as you can see on this particular on the screen right now. So, you have the elementary flow. From the elementary flow, you can get the impact, we can get to the impact categories. From the impact categories, we can get a single score. So, the single score is used to compare between different products, different processes, different systems. So, when you look at the single score, it's easy for people to understand, and the single score is got from the data collected as part of the impact category. And here these impact categories are then the single score has the weightage for each of these categories that is there. So, these different categories have been given different weightage. So, what weightage each of these category will get depends on how you interpret the data, how you put those weightages. So, it becomes a bit subjective. So, that is why there are several methodology out there as well. There are several protocol out there in terms of how to get this like a single score, how to do this weightage. So, there are several guidelines are out there. Presently, there is one method called recipe 2009 that is more common. Earlier, it was impact 2002 plus that was used. There are other methods out there as well, which can be used in terms of getting this single score out of that. So, again you have the LCA result, you get the midpoints, you get this endpoints. From there you get you do some weighting, you get the interpretation, and from interpretation you get to a single score. So, that is this shows you a overview of the methodology proposed by this particular LCA researchers, Goetkop and Sprintsma. The environmental model for each impact category extended up to endpoint level, as the impact category indicates that relate to same endpoint or have a common endpoint. These indicators can be added. In the case of ecotoxicity, the endpoint is ecosystem quality expressed at potential disappeared fraction of plant. So, that is the way things are interpreted as well. Then some of the other stuff we look at, like the emissions to air, water, the exposure level, the disability with several level of severity, what is the disability adjusted life years, weighting of disability, people getting sick of. This is used for model used for human toxicity. This is the schematic representation of the model used for human toxicity. For other substance types and other fate models are also used. So, this is how we talk about in terms of human toxicity data, how to try to interpret all this data. So, those are some examples. So, if you in terms of the LCA, the big picture, you can use it. First of all, you need to know why use LCA, but you need to have a plan for a life cycle analysis, scope, which application, how the results will be used, who will do it, what is the big picture objective of this work. Then you try to have you interface with your organization, then you try to have eco design, strategy development, product declaration, benchmarking, life cycle costing. Then this can be used by the designers, can be used by LCA practitioners in terms of eco indicators, agreement with some source and some details, product managers, your environmental management systems specialist. So, all these the choice of impact assessment depends on the audience you address. If you are talking about designers, you will talk about eco design. If you are looking at the safety development, strategy development or product declarations, you can go to the LCA experts, and LCA, then it can be used for eco indicators, it could be used for the product managers as well. They can use, if you look at the all environmental management systems specialist, they can use that as well. So, depending on who is going to use the data, who is going to use that information, you interpret it in the way so that it becomes useful for that particular person to use it. So, that is how, but basic concept is the same, trying to reduce the environmental footprint of any product, process or system. That is the goal of any LCA exercise. So, if you look at how the environmental profession has evolved, including in for electronic waste, once we have started this electronic waste being produced, people, there was a panic in terms of, there is still a panic in many places in terms of how to manage this e-waste effectively, because we are producing lots and lots of e-waste. More and more e-waste is getting added to the disposal stream. This is the most, there is a huge steep rise in e-waste that is being produced. We looked at that graph as well earlier. So, more and more e-waste will be produced. Now, it is expected that actually there will be more e-waste in the developing country rather than in developed country, because most of this developing country has high population as well, like those BRICS countries, Nigeria, all these high population countries, even the per capita waste e-waste generation is much less, since the population is very high. Effectively, you see more e-waste that is being produced. So, for all this waste management or electronic waste management, or in general even for environmental stuff, the thing was the concept until very recently was mostly focused on cleanup. It is still, now we do a lot of cleanup because a lot of contaminated sites are there, a lot of cleanup is required, but the focus was mostly on restoration, on cleanup, emissions reduction, like end of pipe approach, looking at the end of pipe approach, that is what is called. Now, for last say decade or so, we are focusing more on pollution prevention, like how to have a cleaner production, how design for environment, design for sustainability, green chemistry, life cycle management, all these things are coming into the picture, including in the design of electronics. Nowadays, actually TU Delft, where I had a chance to spend a few weeks like a couple of years ago, they are working on with several electronics manufacturers, Samsung, LG, Sony, all these, they have actually made a consortium and they are funding this project together. Can you imagine that? And to design, so how to design electronics in a more sustainable way. How do we, like because they are also realizing that this the concept of produce, use and dispose. So, that linear economy concept, where I was explaining you earlier in one of the video, that you keep on producing stuff, go to Mother Earth, get the material, produce, use, dump. That cannot last forever, because we need to start recovery of those material, putting back into the cycle. And many times you need to think, do we really need like the whole product needs to be changed? Take that example of your laptop. When you buy, and say if you have an older laptop, 2 years old or 3 years old, and now you are going to buy a new one, maybe 60–70% of the old laptop is still like good enough, still you do not need to replace that. What needs to be replaced maybe 25–30%, because the new processor has come, some new stuff has come into the market, things have evolved to make the graphics to look better, maybe high definition, whatever. So, you have those things to do that, you can replace only 25–30%, but to make that happen, the design has to be more as a modular based design. If it is a modular based design, we can do it. We can we can take those parts away which is outdated, put the new parts in, and maybe update the software, and the computer is ready. So, because the casing, screen and other things is good enough. So, just a little bit of kind of maintenance and some cleaning and other stuff, and can make it look almost as good as a new. So, that's, and with much less cost. So, if there is a less cost, of course, we need to look at how the business model will work, how, because we have to produce jobs as well. So, how the jobs will be created, how the people will get jobs to do this kind of stuff. So, that is the, in terms of we need to talk about in terms of how this newer business model is going to work in circular economy. That's the concept of circular economy rather than going for a linear economy. So, in terms of the LCA, what we are trying to do, we are trying to model the reality. We are trying to model reality. We have a system definition, function, product system, we have inventory. So, product system function and the product system is our economic model, and technological model is our elementary flow, inventory, then impact category, indicator, single score, that is our environmental model. So, we are using these three model and try to model the reality. Whenever you try to model reality, of course, you will have some challenges, because you use a lot of assumptions which is not true. So, we cannot really model reality 100%, we will try to get there. Any limit to the model, it is assessed impact, it is a potential impact, it is not the real impact. So, it is exceeding of threshold, safety margin due to the relative expression of impact scores. So, there is a relative expression of impact score, integration of environment data over space and time. So, that is again the inherent uncertainty of modeling, fact that some impact categories clearly represent future impact. So, based on all that, there will be always a limit to any modeling exercise that we do. Those who are working in the environmental field, and especially on with some models, it knows much better that models have limitations, including the life cycle models. Here we are only talking about environmental aspect. The social and economic aspect is used with the other tool, and in the inventory sometimes you do not have all process and flows, because it gets too bigger, you do not have that information available. Data quality is a question. In terms of the in India, we do a life cycle assessment, life cycle management conference every year, and I am one of the organizing team member there. It's actually done by FICCI in Delhi. So, there last year we had one presentation where the question was asked, okay, what is the major concern in terms of LCA in India? The answer that whether the three major concern, and the gentleman who was presenting it, his answer was data, data and data, because getting good data in all spheres, you look at the water quality, wastewater, even the river Ganga cleanup, having a good data along the river Ganga is always needed. Waste management, in general, municipal solid waste, we do not have a good database in terms of how much waste we are producing, how much is being managed in informal sector, how much really ends up in the dump sites, and what ends up in dump site, what is the composition of that waste which ends at dump site. So, a lot of data is required, and those are again missing. And then we have the impact assessment, what is the chosen impact categories, available characterization model, relevant inventory data. So, all those things needs to be taken into consideration. So, we will end with little bit of development of LCA, how the LCA has evolved over time, and then we end with this LCA part, like introduction to LCA. Then we will look at how this data, how it is being used in different applications. So, development of LCA, it's believe it or not, it started in 1969, even before I was born. So, it's pretty old stuff, but at that time they were not calling it LCA. It was Coca-Cola, in resource and environmental profile analysis of Coca-Cola in USA was done in 1969. They were looking at whether they should go for aluminum versus glass in terms of whether it should be Coke can or whether it should be Coke bottle, and I think they were using for glass versus aluminum cans. So, whether that was done, it was an inherent exercise. There was no ISO standard at that time. So, we do not know whether that we can really call it a LCA, but something like LCA study was done. The first it was done in 1969, mostly from a business perspective of Coca-Cola. Then the LCA study that as we know of today kind of started in 1984, where environmental report on packaging in Switzerland, that is where they started working on that in terms of reducing the packaging. They have been thinking from an environmental point of view. Then the CTAC come up with a LCA workshop in 1991. CTAC has done a lot of work in this area. CTAC, those of you who do not know, it is a Society of Environmental Toxicology and Chemistry. It is a huge organization. It is a pan-world global organization. People around the world are the members of CTAC, and CTAC has done a lot of work in terms of LCA. They were the initial like a flag bearer of life cycle method. Then in then the first European guideline on eco-labeling came. Eco-Invent Database Center was launched in 2000. Before that, in 1997, there was a life cycle assessment journal started, International Journal for Life Cycle Assessment. It's a very popular journal, very difficult to publish these papers in this journal now. Earlier, probably it was not that difficult, but now it's very competitive. Then ISO standard came between 1998, 1997 and 2000, where the ISO standards were developed, and that's what we use it now. Then 2002, the UNEP Life Cycle Initiative, CTAC all came together, and they make this Life Cycle Initiative group, which is now kind of taking this life cycle forward. And 2007, European LCA platform, ILCT handbook came up. And sometime in 2008, 2009, the social LCA guidelines were released. So a lot of things are happening in the LCA sector. So for any topic that you study, try to understand, try to get a little bit of history about that topic. It's always fascinating. See, it's always fascinating in terms of looking at the history. There is like everything. This morning I was teaching a different class, and we were talking about that how you need to tell a story. The technical story in a simple way. That's, if you can do that, you will be a very good, the students will love your lectures. At least students like me will love your lecture if you can tell the technical content in a simple way, and so that it's easy to understand. See, it's very easy to complicate things and makes life difficult for the students or anybody for your audience. To explain things in a simple way and try to break it down, and so that the students can follow it. That's why I keep on telling you, if you don't understand anything, let us know on the discussion forum, so that we can make those amends, we can make those corrections. We are now kind of in the 4th week. You should have done it earlier if you have not done it yet, in terms of telling us that if there is any modification, because I'm putting my effort to make you learn this material. If there is some modification needs to be done so that you learn it better, always welcome. Let us know. Any constructive feedback is welcome. So in terms of, so then the ISO, as I said, ISO came up, and there is a ISO guideline in terms of 14040, which is goal and scope definition, inventory, impact assessment, and interpretation. So we use ISO methodology to do LCA today, and so this is let's kind of give you a very brief description in maybe a nearly 1.5 video, so less than an hour or maybe slightly around an hour video on just to give a quick overview of life cycle. And as you know, that's an 8-week course. So I may not be able to do a very good justice for those of you who have no idea about this, but I wanted to let you know that this is a newer concept, and there is a lot of application of that from an electronics and e-waste perspective as well. So how this is being used? Actually, as probably you know, as I introduced myself in the very beginning of this course, I am essentially a waste management person, and my movement from waste management to resource management, and from the resource management to life cycle analysis, it happened because of e-waste. I was working on a project on e-waste a long back, almost 12 years ago, and maybe more than that, nearly say 10-12 years ago, doesn't matter. Does it really? There we got this project where a company was trying to move away from lead. And because as we explained in this course, as we saw in this course, lead is used in solder, in a soldering iron material. This company was moving away from lead and trying to produce this alternate solder. Now, when they are trying to produce this alternate solder, they wanted to know how much environmental good actually they are doing by moving into this alternate solder. Whether their things will still be a problem from alternate solder, whether things will leach off. When I say things, that heavy metals that are being used in place of lead, and I'll show that to you just in a minute. What were their alternate solder? So this project, and where myself along with my boss and other people, we were developing this life cycle inventory data from the disposal point of view. So when this solder and e-waste containing these solders will come into the environment at the end of life, if it ends up in the landfill, what kind of leaching it will happen? If it goes to a surface water, what kind of contaminant leaching, contaminant release you would see. So we are trying to develop those LCI inventory. So, when we are developing this LCA inventory, then that was the first time I heard that. Then I oh, this is something called life cycle analysis in which it will be used. And of course, I had to study and all that, and then I offered a course in 2008 for the first time on this particular topic. Actually, co-offered this course with one of my colleagues and in New Zealand. And that's how this life cycle analysis journey started for me. Now we have several students who did project on this. We have published few papers, and we are trying to do some work, trying to give courses in this area so that more and more people get aware. This is a very, in my view, it's very much needed in a country like India, or any country for that matter, to have a better environmental policy. The environmental policy which are really going to make an impact. Many times we do things without really going for the science. We have to understand the science. The policy and the science needs to have a good marriage. So, every good policy should be based on good science. So, it's for the good science you need to do it, especially environmental policy, you need to do this stuff in terms of EIA, LCA, and those things are very, very important. And so going back to the first project that I worked on LCA, as I told you that I will give you some examples. So, this was on alternative solder. Now, what is this alternative solder? As you can see, alternative solder, most common solder type is the lead based. You saw this picture in the very beginning of this course, I think, as well. Most common most common solder type is the lead base, which is 60% tin and 40% lead. So, lead, as we have been talking about, lead is not good for health, lead is not good for brain development, lead is, that is why we have unleaded gasoline and lead based paint and all those things we have talked about class. Now, there was a certain alternatives that was proposed. The alternatives A1, A2, A3 and A4. A1 99% tin, 3% copper. So, 99% tin and 0.7% copper. So, that is your A1, and then A2 96% tin, 2.5% silver, then we have copper, and what were bismuth and other things are there. Then we have tin, silver, copper, we have tin, bismuth and 1% silver. So, there are different these are the 4 different alternatives. None of them has lead. Alternatives do not have lead, but they have higher tin in 3 of them. Then in one of them which has less tin has bismuth. So, bismuth, silver, copper for that matter, they do have certain toxicity level, especially for different types of organisms, like copper is toxic to aquatic species, silver has a toxicity number, silver is one of the TC element as well, bismuth has drinking water limit. So, all these has certain type of toxicity associated with that. So, we wanted this particular company who had given us this project, they wanted to know that what happens when these things get into the disposal side, what kind of leachability takes place from these different solder types. So, we collected this data, and so the average we tried to first look at the lead leachability, because that was the number one. So, we had a lead based and then alternatives. Alternatives maybe because it was there in the printed wire board was there. So, wire board maybe blank board has some lead as well. So, that could be the reason why we saw a little bit of lead showing up. So, in terms of average lead leachability from the first, if you look at the lead based TCLP, TCLP is the test, remember we talked about the TCLP is the test which you do to find out whether a waste is a hazardous waste or not. We talked about the TCLP on electronics, how difficult it is to get a representative sample. So, if you do a TCLP test on that, which will simulate what will happen in a landfill environment, SPLP simulates what will happen outside the landfill in a acidic rainfall conditions. So, what we saw is in the lead based paint, lead stuff very high TC, these are all in milligrams per liter. So, 72.5 in TCLP, SPLP or 2.46. Again, why it leaches too much on this TCLP? You should have the answer, because this is what we discussed quite in length in the previous, I think, first week videos, where we were talking about the TCLP. TCLP, what kind of leaching fluid it uses? Sodium hydroxide, acetic acid. So, you have the acetate in solution. lead and acetate makes a very nice complex and comes in solution. So, that is the reason you see lead showing up in TCLP, lead acetate soluble complex. We do not see, although both same sample, we see things leaching off in 72.5 and SPLP is only 2.46. That is almost 36 times less. So, maybe 30 sometimes less. So, why it is so? Because there is no acetate there. In SPLP, it is an acid rain condition. So, we have SOx and NOx, no acetate. So, no lead acetate in solution. So, that is why you see very low. So, it depends on what is the chemistry actually. So, but as per the test, the protocol is there. So, we have to follow that protocol. We already know why acetate is there because of the municipal solid waste landfill acid forming condition. So, we saw lead coming out in both these cases. And usually we compare this with the TC limit to know the hazardous waste or not. We compare this data to the drinking water limit because this is we are trying to simulate a surface water condition. Then A1, A2, A3, A4, you saw those 4 solder types, and the TCLP lead is much less, and blank board has some TCLP lead also and SPLP lead showing up. So, because of the blank board or maybe some other impurities showing up, we do see some lead showing up in these situations. So, it's a lead does show up a little bit in different soliders that is coming out, but much less than what is coming out from the lead based solder. Copper leachability, we saw the copper leachability was actually less in TCLP, and even if you look at the SPLP, it was copper leachability is much less when we look at the copper lead based. When we look at this lead based, it is less, but this is higher than that, this is also higher, this is also higher. So, all these things actually is showing much higher. So, it may be the reaction between them. So, the TCLP copper was much less compared to other from the lead based solder as opposed to the other solder, and SPLP again was in fact was the lowest was in this compared to the others. So, it is in terms of the copper leachability is more. So, if you think about from a aquatic species impact point of view, the newer solder types were actually worse than if you look at these data, newer solder types seems to be worse than the older lead based. If you think about just the copper toxicity to the aquatic species. So, that is although this copper is bioavailable or not bioavailable, that is a different question. We talked about that as well in this class, but that is in terms of so we have to look at these kind of data, what kind of data. So, this data went there in terms of getting into the database. So, EcoInvent database will have these kind of data when you look at the leachability or the potential impact of different categories from these soliders. So, this is the tin leachability, as you can again different values out there. Then we had so average bismuth concentration was below detect for type 2 and type 4 TCLP, it was 14.4 milligrams per liter. And when we look at the solder density, lead concentration was more larger multi-layer boards A1 and A2 we saw slightly higher than the smaller boards has less solder density percentage by weight. So, these are how they were there. So, based on so these are the kind of data that you would generate in terms of the LCI inventory. So, that also is a very big unfortunately we do not that is not considered research. The data collection in many parts of the world including in India, like whenever we go to DST or other places, they say this is not really the research because you are just collecting the data, but collecting this data is also very important unless we have this data. So, maybe the government has to provide some sort of funding from somewhere where we need to collect this data. What is that inventory data? We have to have LCI inventory from the Indian context to do a real life cycle analysis for any product, whether it is electronics, whether it is a different stuff. We need to know, we need to have the data. So, some of the electronics data probably we can use foreign data because it is a similar stuff. We can use the data from abroad, from the literature, but again in terms of the disposal site, in terms of the conditions in the Indian scenario is different than the Western scenario. So, it is always better to have a primary data collected by ourselves in terms of the research. So, if in terms of the LCA research, LCA exercise, especially for an electronic waste, data collection, data generation is very, very important. Even the environmental risk assessment is very, very important. And to make it more environmental friendly, the newer design needs to come in. We need to look at a better design. So, in the next video, which would be kind of the last video of the course, because we are in the 4th week, 5th module, we will get into the 5th module. In the next video, we will talk about life cycle assessment of a laptop computer. This is what we will start with, and then we will talk about some of that how to design a more eco-friendly electronics. So, and then we will end, and then you will have another video which will be an additional video with some solved examples. Some of you have requested or through discussion forum to have some solved examples done of the different types of problems that we have looked into this course. So, we will have that made and uploaded, which will be part of week 4. So, thank you, and again, any questions, feel free to put it on the discussion forum. I will see you again in the next video. Thanks.